Okay, so this is one of the questions from the book, and where it kind of deals with solving trig equations, but with I call it with a twist because it's 3x instead of just x. Now, going back to what we've talked about in terms of trig function, we say, hey, 3x, that tells us the b value is 3, and in terms of transformation words or language, that's basically a compression, a horizontal compression by a factor of a third. So this graph has been compressed by a factor of a third. So that means, okay, I'll start off with this. That means the period is equals to 2 pi over b. Period is 2 pi over 3. And then this is going to be important later on, so we'll save that for later. So for now, what we're going to do is we're going to try to solve for x here. Let's go ahead and do that. Let's put the one with the x's on one side and the numbers on the other side, because this is going to be 1 degree trig equation. So cos 3x, and I take this 5 cos 3x to the other side, so that makes it negative 5 cos 3x equals to 2. And if I take this negative 1, add 1 on both sides, I'm going to get 1 there. Simplify this. This is going to be 1 cos 3x minus 5 cos 3x. That's the same thing as writing it at negative 4 cos 3x equals to 3. And then slowly, we're going to slowly unravel this thing so that the x is alone. So divide by negative 4, divide by negative 4. Negative 4 cancels. You're left with cos 3x equals to negative 3/4. I think at some point in our course, I'm pretty sure everybody can get up to this stage, but this is not what we're going to stop, okay? This is how I normally do this. I'm going to show you a strategy. Maybe if you see another video, they have a different strategy, that's okay too. So what I'm going to do is I'm going to let theta equals to 3x. Okay, so I'm going to let 3x equals to theta. So if that's the case, then I can rewrite this as cos theta equals to negative 3/4. And then because what we've done before, we ask ourselves, wait a second, where is theta such that the cos of that angle is going to be a negative? Where's cos negative? The answer, you would say, hey, that's in quadrant 2 and quadrant 3. 2 and 3. Okay, that's good. So theta would be over here, and then the other theta would be all the way there. So you got 2 solutions, 2 possible solutions for theta. So we'll go from there. Well, what is theta? What is theta? Now, what I'm going to do first is I'll try to get rid of the minus so that I can figure out the reference angle. I'm just going to put theta r, and that indicates a reference angle. We're going to need the reference angle later. So cos inverse of 3/4, okay? So that I can figure out theta r. Cos inverse of 3/4. And I'm going to come up with this number 0.7227. Okay, so well, where is that in our picture? Because you want to ask ourselves, where is that in our picture? Well, that, because the reference angle is 0.7. That's this angle right here, 0.7227. I feel like I'm writing smaller and smaller and smaller each time. Okay, well, what's theta then? If this is a reference angle, what's theta? So in quadrant number 2, theta in standard position is pi minus 0.7227. Is everybody okay with this piece? Right? That's like chapter 1. So that means theta pi minus 0.7227 is 2.41 89. I'll just put 4 decimal places. Okay, I'm gonna leave that alone for a second. Now I'm gonna go to in quadrant number 3. Quadrant number 3, what's the theta there? Theta is equals to pi plus the reference angle 0.7227. So pi plus 0.7227 is going to be 3.8643. Okay, so far so good. Now, you thought that you've come to the final answer, but we're not quite there yet. The question is not what theta is, but what x is. So, remember we said theta is equals to 3x, so we're going to resubstitute the theta equals to 3x into our equation again. So that becomes 3x equals to 2.4189. Solve for x, so divide by 3. X is equals to 2.4189 divided by 3 is 0.8063. So we found the first angle.
Why did we wait to divide it by 3 there?
Instead of here? Oh, because this is a reference angle. We could divide it by 3, but we're going to have a hard time later with this one. Yeah, I think it's more confusing to do it that way, to divide it first. Figure out what your theta is first, and then divide it by 3 after.
After adding it to the pi?
Yeah, yeah. Because these ones are just reference angles. Now, let's do the same thing over here. This is going to be 3x equals to 3.8643 divided by 3. So x is equals to 1.2880. Okay, so I got these two angles. Now, the other thing too is that the solution, the number of solution depends on the domain, right? There's going to be probably infinitely number of solutions, but depends on the domain. The domain in this problem is from negative pi to 0. So this angle in here, from 0, negative pi to 0, that's the domain. That's where we're going to find our x values. The x values that we found are not within that domain, right? This is positive, the domain is negative. So, I think I spoke with some people already earlier. We said what we can do is we can write down the general solution. So the general solution are as follows. It's going to be 0.8063 plus, okay, the period. Well, the period is no longer 2 pi. The period is now 2 pi over 3 times k, where k is an element of an integer. The other one, so 1.2880 plus 2 pi over 3 times k, where k is an element of integer. So I think if we were to solve this using angles in degree, would be a little bit easier because we can see it, we can graph it, but it's a little bit challenging to see it with radians, but that's okay. So what we're gonna do is we're gonna figure out the solutions within the domain of negative pi to 0. So let's see here. If our solution is 0.8063 plus 2 pi times negative 1, I'm going to put the negative 1 because we want a negative angle. Negative. See what kind of number we're going to get. What angle is that in a negative direction?
Is it 2 pi over 3?
2 pi, yes, it's 2 pi over 3. So we're going to get negative 1.28881. Okay, now we ask ourselves, is that within the domain? Is that within the domain? Our domain is from negative pi to 0, and negative pi is negative 3.14. Is that within that value? Yes, so that's okay. What if we go 0.8063 plus 2 pi over 3 times negative 2? Now, I look at that one. This is negative 3.3. We missed it by a little bit, right? So this is, although this is a solution, we're really not considering the solution because it's not in the restricted domain. Okay, so this is not in the domain, x value. Okay, so we only have one solution for this angle. Now what about the other angle? 1.2880 radians. Okay, all of these are in radians. 1.2880 plus 2 pi over 3 times negative 1. I got negative 0.8064, and then, okay, I see that that angle is within the domain, so that we're going to take that as one of our solution. Let's see if there's another one. This is negative 2.90008. Is that within our domain? Yeah, so that's our. And I think if we do another one to the negative 3, then we might go over. Okay, let's just do that. Yeah. So if I go to negative 4, okay, it's going to be way over outside the domain. So therefore, what's our solution? Therefore, our solutions are x equals to negative 1.2881, negative 0.8064, oops, or if x is negative 2.9008. We got 3 different solutions.
What about the first one? 0.81?
The positive?
Yeah.
Oh, no, because it's gonna be over, our solution is between 0 and negative 3.14. So no, only the negatives, yeah,
Okay.
not the positives. It's a solution, but not according to this restricted domain. How's that one? Is that okay? It's a long one. It's pretty intense, but okay. So that's that piece. Okay. I know you have special requests as well, so let's hear your special request. The one with the quadratic, you said?
The factoring one?
The one with factoring? Okay, sure. What number and what page?
12,596.
Okay, so this is question number 12, page 596. There's A and B. Which one do you like?
Doesn't matter.
Doesn't matter? Okay, so let's do B. Okay. The tangent. So it says here, solve each equation. Okay. Now, back in grade 10, you were talking about factoring, like what's factoring for? Well, you've come to this one here, another part of factoring. So when you have this quadratic equation, which happens to be a trig equation, what we're gonna do is we're gonna see if we can put everything on one side of the equation, one side is 0, and then solve for x, right? So that would be tan squared of x plus 3 tan of x, and I'm gonna bring the negative 2 tan of x, and one side equals 0. Okay, so that's great. Tan of x, or tan squared of x, there's no common terms, no like terms, but these two are like terms. You can think of it that way. So 3 tan of x minus 2 tan of x, that's going to give us 1 tan of x, or tan of x equals to 0. Okay. So how do we factor this one? We're going to end up with a binomial. When you think of it as a polynomial, it would be binomial because you've only got 2 terms. Strategy would be find a GCF. What's a GCF between these two? Tan of x, right? So let's say factor out the tan of x, and if you factor out tan of x, what's left over?
Tan of x plus 1.
Tan of x plus 1 equals to 0. So now, this is called a zero product property. So if this value is 0, and if you multiply with something, it will give you 0, right? So what will make this 0? Tan of x equals to 0. Well, where is tan 0? Let's take a look at that again. Because tan is equal to
Sine over cos.
sine over cos. Well, how can it be 0 if sine is 0? When the numerator is 0, right? That's why. So where is tan 0? When sine is 0. Sine is 0 where? At 0, pi, 2 pi, right? So x, however many solutions, so 0 radians, pi, 2 pi, and so on, right? So those are your solutions. Okay. We'll deal with the restrictions later. Now you look at this one. Tan of x plus 1 equals to 0. Tan of x equals to negative 1. Where is tan of x equal to negative 1? Okay, remember, tan of x is equals to sine of x over cos of x. So we need to have them the same, but one is positive, one is negative. So where is tan? Negative 1. Tan is negative in quadrants 2 and 4. So what would that be? Pi by 4, right? The reference angle is pi over 4, so this one here would be 1/4, 2/4, 3/4. Okay, let me just see what the domain is.
Negative 90.
Oh, okay. Our domain is from negative 90 degrees. All these times we're doing it in radian. Okay. Tan is negative 1 over here. Our reference angle is 45, so that becomes 135. And then this one would be 315, right? These ones, we're going to scrap this because our x has to be in degrees. So what would that be? 0, 180, 360, and so on. Okay. So in terms of our domain, does any of these fit in our domain? Our domain is from negative 90 to 270. So you already know that I like to break things up. Okay, so are there any solutions between 0 and negative 90 for this? So within our domain, what's our solution? So 0 fits, right? Degrees. These are degrees. Okay. And that's it, right? So 0 to negative 90, right there. Okay. Now what about from 0 to 270? Does this fit? Yeah. Does 360 fit? No.
Please excuse this brief interruption. Tao, if you're in a school, can you please come to the office? Thank you.
I was in trouble.
Okay, now what about this one here? From 0 to negative 90, or negative 90 to 0. What's this angle right here? Negative 45. So we're going to put x equals to negative 45 degrees. Now what about from 0 to 270? 135. 135. So this one is good. This one? No. So how many solutions do we have? So therefore, the solutions are, okay, so for this one we have two solutions. X is equal to 0 degrees and 180 degrees. Now for this one would be negative 45 degrees and 135 degrees. Get 4 solutions. Okay. Is there anything else you want us to take a look at? So we did question 9, one of the questions in question 9, one of the questions in question 12. Is there anything else? Do you need time to finish the rest?
Oh, you mean the rest of the question?
The rest of the questions? Or should I continue on with the notes? Finish? Okay, so everybody will stay and finish? Yeah, okay.
9 to 15?
Hmm?
9 to 15?
Yeah, 9 to 15. Okay, so we're giving us a valuable time in here, so let's take this time to finish. If for special circumstance that you're completely finished, anybody here who's finished up to 15? Nobody yet? Okay, well, that's good.